Hello everyone. In this video, we are going to study what is called measures of variation and what are the types of measure of variation we are having. So what is the difference between measures of central tendency and measures of variation? Suppose you have not studied what is called measure of central tendency. I have given a description in this description box. The previous videos of measures of central tendency, kindly have a look. So here we are going to study about the range, okay, then interquartile range, I'll call it as IQR. Then we are going to study about variance, then we are going to study about standard deviation. So most of the time we have to understand what is the meaning of distribution here. Okay, now whenever I say what is called a distribution, so in order to know what is called a distribution, we are going to have an example here. After the example, then we will move on. What is the use of measure of variation? Why it has been used? What is the difference between the measures of variation as well as the measures of central tendency? We'll quickly move on to an example here. So imagine that you are having some number of students, as everybody is having a students in your college, or the students will be studying in a college. So we'll be having a simple example here. There is a test score given here. It ranges from 10 to 90, for example. We are having a test. We are conducting a test, and if a person scores 10 marks, I'm going to mark it on the line which is saying 10 marks. And I'm going to just mark an into mark here when students score 20 marks, etc. See, for example, I'm going to mark one student. Okay, now this particular one student scored 10 marks. If it is two students, I'm going to mark it here. Okay, mark it here. See, suppose there are two students got 20 marks, for example. No, it is not necessary to be equal at all. Okay, so one student may get some 15 marks. Two students may get 15 marks also, some 25 marks also. Some people will have like this. I can mark it, okay, whichever is the mark. Now for clarity, I have given it as 10 to 20, etc. Okay, so now when I mark this, I'll be having a marking like this. Okay, now this is called the distribution. We are going to have it here. Some values here also may come here. I'm going to mark it here, mark it here, mark it here, mark it here. Now when there is a particular class, so there should be some students who score less marks, from 10 to 20 also. Some nice students, sometimes they score 80 to 90 marks also. Here, all the students are equal only. So they'll be scoring less mark because of some reasons. Now, when I want to draw a diagram, okay, so like this, I'm going to draw a diagram and show it to you now. So you'll be drawing a diagram by touching the points here. Now, this particular thing is called a distribution. Okay, so usually we call it as a bell curve here. So we are not talking about the bell curve now. For time being, we'll say this curve represents a distribution. So when I draw a curve, it represents the distribution. Now, when we talk about measures of central tendency, now this is the peak here. This is the highest number of students. So this will give you mode for you. Now, which cuts the students distribution into two equal parts. This is the line. Okay, now this is the line. So this is a median. Then this is also a mean for you. So now we'll be having mean and median, and mode will be in a one place, central place. That is called the normal distribution. We'll be having a separate video to find out what is called a normal distribution, why we are using. Okay, so in days to come here. Now you remember, whenever I draw a thing like this, so I will call it as a distribution. Here, the center point will be the mean. That alone you remember now. So once we complete, we will do a separate video for normal distribution. Okay, say right. Now here, this curve represents a normal distribution with mean is 50, which is in the middle, and the standard deviation is here. You see, standard deviation is here. Now 50 to 60, I am having 10. From 60 to 70, I'm having 10. So 10, 10, it is jumping. Okay, so you can find it out. So whenever I say this 50, I'll call it as mu. Then the 60, I'll call it as, see, 1 sigma. That means what? Mu plus 1 sigma. That's the meaning for this. Now I am considering the area, that is that the area between this is mu plus 1 sigma. Similarly, when I go for this, I'll call it as mu plus 2 sigma. So this is how we are going to define this curve. So we'll be having a normal curve separately for standard deviation. Okay, now what are all the measures of variation we are going to study here? See, first we should understand what is it actually. It is also called as a measures of dispersion. So how dispersion means? So distributed value, how the values are distributed. See, now it describes the width of the distribution. It describes the width of the distribution. How? See, I'm going to show it in the diagram here. Now this is called a curve. Okay, this is a distribution here. Now it ranges from here to here. So now this is the width for you. Now this is, I'll call it as a width. So my measures of variation will talk about the width of the distribution. So from which previous example, I can take it from 10 to 90. It's the width I'm going to have. Like this, it is showing the width of the distribution. Right. Now, what else it will tell? It summarizes how far each of the value is from mean. Okay. I'm having one value. See, it differs from mean how far. That's what I'm going to see. See, now, this is the distribution here. This is the line which represents the mean here. So this is the mean. So I'm having a value here. Okay. This is a value for me. So how much it differ from the mean, it will show, right? Now that's called the measures of variation. I'm having another value. So it is a little bit far from mean. So that is what we are going to measure it in the measures of variation. Okay. So these are all the 4 values. You can have it right now. It is used to measure the scatter of the values, how the values are moved. Okay, so this is what I'm going to show. This is a distribution. This is my values. Okay, now it is clustered here. It is away from this. It is away from this. It is away from this. This is what we are going to study in measures of variation. Okay, so now what are all the things we have to study from here? Measures of the variation. See, now we are going to have an example here. I will show what is it. See, now remember, I'm having an x-axis. I'm going to have a usage of cell phone, for example, for 10, 20, 30 minutes, up to 130 minutes. We are going to use a cell phone for the 3 types of students. One is the secondary students. Okay, secondary students. Then we are going for college students. Then part-time working students. Okay, so now how much they are using the cell phone? Everyone are using for 70 minutes as an average. So we cannot tell about who from which are the value, what is the spread and all. Okay, now it shows the difference for you. See, for example, this I will take it as a secondary student. So now they are starting from 0 to 130 minutes. They are the people who are using the thing. Okay, using the cell phone. For example, the middle value is always 70. So I cannot tell anything about this. Now, this is the middle value. I'm going for another student, a red color, that I'll call it as the college students. They start from 30 minutes to 110 minutes only. They are above 110 minutes. They are not using the cell phone, for example. So then here also mean is 70. Now I'll go for the people who are working here. They start from 40 minutes to 100 minutes. Only they are using their average also 70. So whenever I go for variation only, this I can mention. They are using it from 10 to 130 minutes. They are using it from 30 to 110 minutes. They are using from 40 to 100 minutes. So I can tell here. Okay, so now this is how measures of variation is differ from measures of central tendency, even though the average is 70 here. Okay, now what are all the measures of central tendency? Usually, okay, it is commonly used. So it is the range. So whenever we go for range, it will be having coefficient of range. Okay, coefficient of range. Then we'll be going for a quartile, interquartile range. I'll call it as IQR. Then I will call it as variance. Then I will call it as variance here. Variance will be used, and then that's for the standard deviation. These are all the 4 major form we are going to use it. So what are all the things we are going to study one by one here? So first we want to study what is called a range. Range is nothing but, see, the difference between the highest value and the lowest value. It is very simple here. So to calculate the range, subtract the lowest value from the highest value in the distribution. So now, what is called interquartile range? Why it is being used? Interquartile range, you know, it is nothing but Q3 minus Q1, I'll tell you. So imagine that I'm having a smaller distribution here. I am splitting into equal parts. Then I'm putting a line in the center. This is called median. Median will be written as Q2. Now I'm putting one more line so that this part is 25%. This part is 25%. The middle part is always 50%. Okay, now I want to know this 50% from which value to which value in the distribution. So that is what your interquartile range will tell you. So 50% of the distribution falls within which range. Okay, that's what is the interquartile range will tell you. So that's what we are going to study. It is a measure which shows the spread of the middle of your distribution, how much it is spread. Okay, now 50% value where it lies. So now the formula is Q3 and Q1. It's called quartiles. This is the third quartile. This is called the first quartile. Now the first quartile and fourth quartile have 25% value here. And the interquartile range will have 50% of the value. We are going to show it in the diagram here. You can see here. Now this is the distribution here. I'm going to have the quartile. Okay, now I can call this as quartile 1. I'll call this as quartile 2. And this is the distribution. It will show from this value to this value. Okay, this value to this value, my IQR will sit. Okay, now this is what is IQR will tell you 50% of the value. From this to this, what is the area? That's what is shown by interquartile range. Now I'll go for 25% here. I'll go for 25%. This is the interquartile range for you. Now we'll move on to the variance. What is the difference between the standard deviation and the variance? Most of the people will be having this doubt. Okay, so if you ask somebody, they will say standard deviation is nothing but root of the variance. Okay, they'll call it as root of variation. This is only for calculation purpose. So then why not? Why variance? Why not standard deviation? Some question may arise. So we are going to have the difference between variance and the standard deviation here. Now keep it in mind. See, this is a single data. Okay, a single value, and we'll be having some group of value. Okay, now whenever we call variance and standard deviation, these two terms will be important. So one is single, another value is group. Okay, now so the variance measures the average degree to which each point differs from the mean. Each point. Okay, now it is nothing but the average squared difference between the values from the mean. Okay, so this is for only calculation purpose we are using it. First you have to remember, see, now it is measuring the average degree to which each point differs from the mean. I'm going to show a small example here. Here the variance measure the average degree to which each point. Okay, now this is a mean. Now I'm having an individual value here. Okay, now the average degree. So it will measure the average degree by which. So imagine that how much it is differ from the mean, the individual value. Now, when we go for standard deviation, we'll talk about the group here. Okay, now, so looks how spread out a group of numbers is from the mean by looking at the square root of the variance. That's what we are going to study here. Now, listen, here, this is my mean here. Now I'm having a group of value. Say how much is the degree of the difference from mean, the group. That's what is there. Now, whenever my curve is like this, I will call it as peak. Okay. Now this part I'll call it as peak, something which is called the flat curve. Now, what does this peak and flat will tell you? Right now, whenever there is a lower standard deviation, the values are close to the mean. Whenever the flat curve, that implies a bigger SD. Whenever there is a peaked curve, implies the smaller SD. This is what we're going to show it in the next example here. See here. Now, the peaked curve will be having a smaller SD. The values are close to mean here. I'm going to show it in the diagram now. You see, this is a steep curve. Now, it will be having a smaller standard deviation because the width is smaller here. Now, whenever the width is smaller, just like a room, we are having a smaller room, so the people will be standing next to them very closely, right? Just like this. So you can remember. Now, these are all the values you are having. Now when there is a flat curve, now the width will be more here. Now, This is a flat curve here. The width will be more, the values are scattered more. Okay. So this is what is about standard deviation. Okay. So width is more. So for standard deviation, we will be having a rule called empirical rule. Okay. We will be doing it in the next video. Okay. Thank you very much for watching. Have a good day.